Hello, everyone. Good evening. Am I audible? Hello. Hello. Good evening to all. Am I audible? Okay. Okay. Good evening to all of you. My name is Ram Kumar Desmukh, and I'm PhD scholar at IIT Roorkee, the Department of Paper Technology. So, uh, so before starting my class, I'll briefly introduce myself because many of you, maybe some new people will have joined here. So I have done my bachelor's degree in dairy technology from College of Dairy Science and Food Technology (ICR) Durg, and after that I joined for MTech in Food Science and Technology in Sambalpur University during 2016 to 18. After that, I had done a job in NIPTAM Tanjavur as a junior research fellowship from October 2018 to December 2019. Then joined as I joined as a project assistant at this present institute, Indian Institute of Technology, Roorkee, paper technology, under the guidance of Professor Kirtiraj K. Gaikwad. Then in 2022 January, I joined as a PhD scholar in the same department. Apart from that, I have done some internship or project exposure I have during my BTech as in plant and uh, work experience, you can say. So all of you know that in this class, what we do, we discuss about the previous year assignment, and we discuss about those questions and how can we solve those questions. So I'll be happy to answer your queries and help to solve those questions. But as we have instructed, like we cannot discuss at this year the same assignment because that will be like cheating. So here the first question is match the pair of food product in column 1 with its pH in column 2. So here what you need to do, you just need to connect the what will be the pH of a given product, and the pH is given on the right side of the product. So there are option A, B, C, D. So if you can see, you can see that one for A option first will be for less than 4. So you can, if you know that, you can select the right answer. So I'll be waiting in the comment box. If you know, please answer in the comment box. Okay, good. Divyendu. So Divyendu, where are you from? Okay, so you are doing MSc or what? MSc in food science, microbiology. Okay, okay, good. Huh? No, 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 no. Just that. Okay, so answer is C. Your answer is right. The apple has a pH less than 4, and it generally ranges from between 3.3 to 3.9. Tomato pH ranges from 4.3 to 4.9. The pH is generally pH of milk is generally ranges from 6.7 to 6.9. So these are the pH range. Every food and every food commodity has their pH. It ranges from uh, 1 to 14, but mostly the food commodities ranges from, I think, 3 to 7 or 8, I think, because food cannot be too much basic or too much acidic. So it ranges on this range. So this is like called high acidic food, medium acidic food, low acidic food, these kind of things. So Divyendu, you are right. For this question, the answer will be C. And second question is a numerical question. Like the tomato juice is flowing at the rate of 1.7 meter cube per hour through a holding tube in a aseptic processing system. The holding tube has inside diameter of 4.35 centimeter and the flow is laminar. The residence time of food in the tube is 2.5 minute. Calculate the length of holding tube. So you need to find out the length of holding tube. So if you know, you can solve. I'll give you 5 minutes to solve this question. For this question, you need to know the formula. If you know how you can connect with the formula, then only you can solve this question. So I'll give some time to solve this. Then we will see the solution for this question. Okay, so what will be the answer? Answer is sorry. Okay, so answer is like for this question. For this question, you need to know the formula that velocity is equal to flowing flow rate upon the upon area. So your tube will be like spherical on the edge. Okay, so what will be the answer? Q is a flowing rate that you know, and you need to and you need to know the what is the formula for this this thing. So 3 point pi r square upon 4. So that will be the your area. So upon that, upon solving, it will come 19.07. And by that formula, length of the holding tube Vmax, when you know Vmax, that will be Vmax into residence time. So Vmax you got, Vmax is 2 into average, that is 19.07. If you will multiply that 2 into 19.07, it will be 13.4, 13.14, okay, 38.14. Then length of the YouTube length of the holding tube will be Vmax into residence time. We have residence time of 2.5 minute, and we have a Vmax is equal to 38.14. 14. So you will what you will multiply 38.14 into 2.5. So answer will be coming 95 point something. Okay, it is not it is it has given 38.14 22, but it will be 38.14. So answer will come like C, 95 to 96. So this will, like this you will solve this question. So for this you need to know what will be the your area of your spherical or tube. uh, Prakash, can you mute? Okay, so like this you will solve the question, this question. Then question third is the initial concentration of ascorbic acid is in aseptically packed lemon juice is 90 mg per gram per 100 gram, and final concentration after storage of 150 days is 70 mg per 100 gram. The loss of ascorbic acid follows first order kinetic with a rate constant of 0 0.00542 per day, and the activation energy is 7 70,110 joule per mole at room temperature. Calculate the storage temperature in degree Celsius. Assume the value of R, universal gas constant, 8.314 joule per mole K. Okay, you try to solve this, then I'll explain. Okay, so we'll see the formula. The degradation rate constant K1 we have given, it is 0.00542 per day. Initial concentration is 90 mg per 100 gram. Then final concentration is 70 mg per 100 gram. Activation energy is 70110 joule per mole. From the first order reaction, what we will first find out what will be the K2. So in the formula it is log C upon C0, that is final concentration upon initial concentration, equal to minus K2 into T. So uh, we have a final concentration 70 mg upon 90 equal to K2 into 150, because we have the storage time is 150. By this we can calculate the K2. Then you will apply the formula that log K1 upon K2 equal to EA upon R 1 minus T2 minus 1 upon T1. By solving this you will get the T2 will be 286.01, and you can calculate from the uh, like uh, what you will do, temperature plus 298 K. By this you can calculate the temperature in the Celsius. Like this is a temperature in the Kelvin. So you need to that convert into the degree centigrade, and the degree centigrade formula you must know, that temperature in in Celsius plus 293, I think, if I am not wrong. Okay, so you check it. If it is you check it and you calculate, the answer will come around 12.94 degrees centigrade. Then question 4, method of food antimicrobials in a column A, match the food antimicrobial in column A with their natural sources in column B. So here what you need to do, different kind of food product contain different acids or active compounds or acid that has an antimicrobial property. So you need to find out that what can be the match of this given product, or you if you know the acetic acid, which kind of product contain acetic acid, so you can connect like properly. So options are given A, B, C, D. So you tell me what will be the answer for this question. You can answer in the comment box now. B, Divyendu. Okay. Anyone? Prakash Maurya. Okay, B. Good. Okay, so answer B is correct. So, like I told yesterday in previous class, that if you know one answer, you can connect with the several several answer. Like if you know the acetic acid, that is the product of that contains in a vinegar. Okay, or vinegar. So you can like see there are two options, one C, that will B and C. So you can eliminate two options like A or D, because A D there is no correct options. Then you can go to second option like propionic acid, which is the answer like propionic acid in found as cheese, that is responsible for their flavor or those holes, I think. So you got two answer. So that is also for they have same like 2D 2D. So if you know the lactic acid or sorbic acid, then you can find out. Suppose if you don't know the sorbic acid, you can go to lactic acid, and lactic acid yogurt contains lactic acid. So you can connect like this. So the now like this you can eliminate the answer C, and your final answer will be B. So there are several natural sources of food antimicrobial, like vinegar contained acetic acid, propionic acid is found in Swiss cheese, that is a and sorbic acid available in the rowan berries, and lactic acid produced by the lactic acid bacteria that is found in curd or yogurt. So like this uh, you can work like this match following, or some question you have given in some exams like net also gives some exams like this to match the your A from right side to left side. Okay, like they will give you product or their chemical compound, or they have given some process and they will give some temperature. So if you know one or two answer, you can find out what will the right answer for that question. Huddle technology is a combined method technology for food preservation where combination factor act antagonistically, symbiotically, synergistically, all of the above. So this is a very very simple question. You all can answer this question. So please write your answer on the comment box. Huddle technology is a technology where different preservation or processing techniques combine and they work. Like suppose you are preparing some food product, so you need to apply different process technology. Suppose you are heating it, you are doing microwave heating or microwave cooking, then you will apply some chemicals, some salt, some spices, so that will also add in the into the technology. Then you will go for the packaging also. You apply maybe aseptic packaging or high temperature uh, processing, or like HPP you apply. So any kind of technology or processing you are applying to make your product safer for longer time. So they combinedly call huddle technology. So suppose you bought one product, it is suppose you bought one pickle. So if pickle you will get it, there is a, it will contain in the glass box. It has a tight uh, lid on the top. So you have to open the lid. Okay, so that is one hurdle, because you have opened the lid. But after opening the lid, you will find one aluminum foil also, that is laminated on the top, that is also added into the huddle technology. Because for going to the direct product, you have to face that huddle also. Then you will go, if any micros is going to inside the product, it will go inside the pickle. And pickle is very acidic and salt, and sometimes if it is sweet product, sweet your pickle, so it is very, the sugar content will be high. So microbes or some things, they cannot grow in this kind of environment. So these all things called huddle. You have to you have to go to different huddle. You have to pass through different phases, 1 2 3. What we suppose, we make one home. Okay, we make one home. Different homes make one society. So different society has a boundary, so that is one layer. Then your home will be also boundary. Then your home is also have doors. So these are different different they are different hurdles. If anyone is want to enter your home, he needs to pass every hurdle through proper channel, or whatever he people he has to pass all the hurdles. So the question is, what that all the combined process called? Combined process work, how they will work, like antagonistically, symbiotically, synergistically. So answer will be answer will be synergistically. Okay, synergistic means you work together. Suppose you are giving heat treatment, then you are packaging. So heat treatment and packaging, they will work together. Antagonistic means they will work uh, uh, what against. So they don't work against now. If you are making any product, every every processing technology, you are uh, you are cutting, you are cooking, you are adding some salt or spices, so they will work together. All things will help to preserve your food for longer time. So that word is called synergistically. That's why when we you have also heard in some conference or some speech, they what they call, if we work synergistically, we will grow as a biggest economy in the world. So they their mean is, if we work together, if we united and work, so we will grow together. So these all huddle technology, these all processes, they combinedly work together. That is called synergistically. So we can preserve our food for longer time. So what will synergistically? The concept of huddle technology utilizes the benefit of combination of several factors which act synergistically. When synergistic parts work together, they accomplish more than they could alone. Means if we apply only heating, or if we apply only packaging, that will be not enough for saving any product. Okay, so if we combine all the technologies, all the processes, that will be more reliable, and it will sustain for longer time. The other technology can avoid the severity of one factor for preservation. Combination factors act as a synergistically. So answer is synergistically. Question 6. Fill in the blanks. There is a dot is an antimicrobial, a primary iron binding compound which is naturally present in milk and colostrum. So you must. This is a very simple question. Also, if you have read dairy technology or dairy any, if you are preparing for some exam, net or uh, something, some competition exam, so you must know the answer for this question. Please answer in the comment box. Which of the given which of the given is an antimicrobial iron binding compound which is naturally present in milk? So answer B, Divyandu. B. Okay, good. And anyone? So their options are lactobimine, lactoferrin, lactose, and lactate. So your answer will be one of those options. So answer is lactoferrin. Lactoferrin is an antimicrobial, a primary iron-binding compound which is abundantly present in the milk and colostrum. So lactoferrin is the answer for this question. Which of the following is not a principle or objective of hurdle technology? So I told you more. I told you about the hurdle technology. So which of the following is not? Okay, you have to care about this not. Direct killing antimicrobial spores, affecting the microbial stability by interaction of several factors, preventing the manipulation of microorganisms, disturbing the homeostasis of microorganisms. So you need to answer which of the following is not a principle or objective of hurdle technology. So please answer. Okay, you answer. Meanwhile, I'll come back within minute. Within minute. Okay, who has given the answer? Divyendu is saying direct killing microorganism spores. Okay, let's see. Okay, so preventing the manipulation multiplication of microorganisms. So hurdle technology is to reduce the multiplication of microorganisms. Okay, maybe the other answers are not that much correct. Okay, but our objective is to reduce the microbial or any kind of intervention that will reduce the quality or reduce the shelf life of the product. So here three of the answers, A, B, and D, is a some or principle or objective of the hurdle technology, but preventing the manipulation multiplication of is not preventing the multiplication. Oh, that is the principle of let me principle of hurdle technology was the multiplication. Okay, so answer A is correct for this. I think I have. written it wrong. Okay, good. Vyandu, you are right for this question. Okay, so answer A will be the correct answer. Direct killing microbial spores is not a principle or objective of hurdle technology. And other options are the objective or principle for the huddle technology. So principle of huddle technology involves the use of preservative factors, huddles that disturb the homeostasis of microorganisms. The microorganisms are not able to jump over all the hurdle present in the food product. Preservative factor present in microorganism from multiplying, causing them to remain inactive and die. The huddle concept illustrates that complex interaction of temperature, water activity, pH, etc. are significant to the microbial stability. Direct killing spore is done by the method of sterilization. So direct killing of spores are done with the high temperature, that is sterilization, that is more than 130 or 135 degrees centigrade. So that one option one will be the option the answer for this question. That is a direct killing of microbial spores. So again, we have a question of match the following with your chemical name. So as I told you, this if you know two or three answer, you can answer all the you can answer for this question. So please write your answer for this question on the comment box. For vitamin C, what is the chemical name of vitamin C? Vitamin D3, vitamin E, vitamin K1, vitamin K2. So if you know two, I think if you know uh, two, you know the answer. Or yeah, yeah. If you know the to answer, you can tell what is the answer for this question. So you have to eliminate one by one, then you will get your answer. Okay, good. Divyendu and Maurya. C. C is the correct answer. The chemical form of vitamin is a retinol. So if you know the retinol, one, five. So we have a three answer A, B, C. Then for if you don't know the vitamin D, we can go to three answer vitamin E. Vitamin E is tocopherol. Okay, so you go three is three. It is not three is three not three one. So this is three one. So you now you see you know only two because I also knew the A and for E. So this is the answer. Like you can eliminate other answer other options and you will get your correct answer. So for vitamin D3 it is a cholecalciferol and vitamin E is a tocopherol, vitamin K1 is a phylloquinone and vitamin K2 is a menaquinone. And what is the general and operating temperature range for a UST process for milk? You have to tell what is the UST process temperature range for milk. If you know the answer, please let me know in the comment box. Okay, Divyendu saying C. Okay, for that question, I think. Sorry. Divyendu saying C again. Okay, Divyendu. And I would like to tell you all people like if you have any question, you can also mail me in my email ID, or if you want to get this PPT, you can avail through the link in the NPTEL website. I think NPTEL team upload that link where you have linked from where you have joined this class. So you can get those data PPT also. And after doing this, we are going to upload in the YouTube channel, and we also will upload that YouTube channel link on the on that website, that link website. Okay, so it all will be shared with you. So whenever you need any whenever you want to see, you can see, you can click that link and you can see on the YouTube also. So this is not for only live classes. You can also join, or you can also attend this class if you cannot attend now, or whenever you want to attend in future. So all these facilities are available in this NPTEL. Like NPTEL, if you classes you attend, okay, so those classes are not live. They have recorded earlier, but but you can attend anytime because it's all available on the internet or YouTube. So you can attend anytime you want. Like these things also will be available in future. So what is the range? The range is C. Okay. In aseptic packaging, the general temperature is 130 to 170 temperature range. Condition are generally referred as a UST temperature. Generally, UST temperature is 135 for milk is applied, but that differs from plant to plant and climate condition also. So, but in general, the ranges of temperature is from 130 to 170 degrees centigrade. Which of the following statement correctly state the definition of aseptic packaging? So we have uh, earlier classes we have seen the what is aseptic packaging. So which of the statement correctly states, you need to define what is aseptic packaging. So these four options, which option is correctly differing or correctly stating the aseptic packaging, you need to tell. First option is heating the food after it has been placed in the container. Heating the food immediately packaging it aseptically. Heating the food and then packaging it aseptically, followed by cooling. Heating and cooling of the food, then packaging it aseptically. So give your answer on the comment box. If you know the aseptic packaging, you can answer this question. For this, okay, Prakash More is saying D. Okay, D is the correct answer. In aseptic packaging, the food is sterilized and cooled, followed by the packed under the sterile condition. So in a aseptic packaging, what happens? You pack your food product inside your container, then you heat, then again you cool it. In aseptic condition, there should be not any intervention of any visible or invisible microorganisms. So it will be longer, it will be stable for longer time. Like you have seen tetra package also aseptic packaging. You have seen the tin container that are also aseptic packaging process. So this kind of process operate under very aseptic conditions. Aseptic means there should not be any presence of any microorganisms, whether it is microorganisms. If you are saying microorganisms, so if there is a no invisible microorganisms or any visible microbes, so there should be not any visible also. Okay, any kind of dirt or anything, that is called aseptic processing. Okay, so for this question, the answer D will be the right answer. Which of the following are two most important factors that provide commercial sterility to a food product? Okay, so you need to tell which of the following two are the most important factor that provide commercial sterility. Commercial sterility means when product goes out in the market, which of the two factors are responsible for its longer shelf life or longer availability. So answer A is option A is temperature and pH. Option B is temperature and solid concentration. Option C is water activity and solid concentration. Then D is water activity and pH. So you need to tell what is the correct or what is the two most important factor that is most important for commercial sterility, or that provide commercial sterility to a food product. Okay, comment in the box. Okay, so we will not wait that much. Okay, so temperature and pH, that is are regulating, that regulates the regulates the shelf life of your product. So in most commercial style food product, temperature and pH are the most important factors that that depends the commercial stability of the product. So answer A is the correct answer. Which of the following is found in only in animal? Steroid, terpenes, cholesterol, phytosterol. So you must know this. Please answer in the comment box. Okay, Prakash Maurya, C. Anyone? So cholesterol is the right answer, because sterols or cholesterol are derivative of steroids that are commonly in eukaryotic cells. Terpenes are lipids that are composed of two or more 5 carbon isoprene unit. Cholesterol is a main animal sterols. Uh, Phytosterol are structurally related to the cholesterol unit but differs from the cholesterol in the structure of side chain. So answer is C. Cholesterol is the right answer. And which of the following can be physicochemical hurdle to preserve food under the hurdle technology? So in hurdle technology, which of the option is a physicochemical hurdle technology? That is aseptic packaging, ionic radiation, low redox potential, modified atmosphere. So by eliminating also you can know which will be the answer. Physicochemical, that will also involve physical and chemical. Okay, so answer your option in the comment box. Okay, answer. Bindu saying C, good. Anyone? Arthi Ravi Kumar saying A, aseptic packaging. Prakash Maurya is saying C, good. Okay, so aseptic packaging, ionic radiation, and modified atmosphere. These are all physical technology or physical hurdle technology or techniques. Okay, modified is a packaging technique. Okay, so it is physical. Aseptic packaging is also packaging. Ionic radiation, that we provide some ionization. Okay, that is not physical or chemical, but redox potential itself present in the your uh, your product. Okay, that you can regulate or you can control the redox potential of your product. So it will be the uh, physical and chemical hurdle technology to preserve your food product under hurdle technology. Okay. So any confusion in all of the questions? Because for today, I think we have this much question only. So if you have any question, you can ask, or uh, thank you for attending the class. I hope you like it, and in next class we will meet next week. So till that day, uh, thank you. Or if you have any question, you can mail me on the my given mail ID. Okay. Okay, my email ID you can note from the screen. If you have any question or any kind of confusion, you can contact me through my email ID. Okay, so thank you guys for attending the class. Thank you very much for the patience. And if you have any question, you can ask me or you can mail me. Thank you so much. Okay, see you next week. Thank you all.